You heard the name. 3I Atlas, October 30th. Closest to the sun, third interstellar visitor ever confirmed. Social media went wild. Mothership theories, alien probes, government silence. Here's what actually happened without the noise. July 1st, 2025. Atlas telescope in Rio Hurtado, Chile catches something moving wrong. Too fast. Wrong angle. The asteroid terrestrial impact last alert system was built to find rocks that might hit us, and this thing lit up their boards at 5:15 Universal Time. Within hours, 31 observatories across the planet start tracking. 122 observations pile up before the Minor Planet Center even names it. They give it C/2025, and Wantasi, then the designation that matters. 3I, third interstellar object confirmed. Not from here. 1, I was Oumuamua in 2017, cigar-shaped mystery that tumbled through and vanished. 2, I was Borisov in 2019, normal comet, just from somewhere else. Now 3, I Atlas, different from both, bigger, active, chemical signatures nobody expected. And it was heading straight for perihelion behind the sun where Earth couldn't watch. If you value documented astronomical research like this, subscribe. It's the best way to support our work. Also comment from which city you're hearing this from. This script is researched and factual, using sources from NASA's Jet Propulsion Laboratory Horizon System, updated October 29, 2025, and peer-reviewed observations published through A-Archive preprint server by Qicheng Zhang at Lowell Observatory and Carl Baddams at USS Naval Research Laboratory on October 30th, with additional spectroscopic data from the Very Large Telescope team led by Thomas Puzia at Pontificia Universidad Católica de Chile, published August 21 through Archive 2508.18382. Now back to the information. Pre-discovery images show it was already there. NASA's Transiting Exoplanet Survey Satellite caught it. May 7th through June 3rd, 2025, 6.4 astronomical units out. Already bright, already active. Water shouldn't sublimate that far from the sun. Carbon dioxide shouldn't be glowing like that. But it was 2 months before anyone knew to look. Vera Rubin Observatory in Chile accidentally photographed it during science validation from June 21st to July 3rd. If they'd started validation 2 weeks earlier, they would have found it first. The coma was growing. June 21st, 13,040 kilometers across. July 2nd, 18,760 kilometers, nearly Earth's diameter already. Something was waking up. Then Atlas spotted it for real. Deep Random Survey Telescope, David Jewett and Jane Liu at Nordic Optical Telescope confirmed on July 2nd. Clearly active, diffuse coma, potential tail, 3 arcseconds, not an asteroid, a comet, from another star system, racing toward us at 61 kilometers per second, over 200,000 kilometers per hour. Hyperbolic orbit, not bound to our sun, just passing through. Hubble turned its eye on July 21st, 277 million miles out. The image showed a teardrop cocoon of dust, reddish, fine grains, tail pointing away from the sun like it should, but something was off. The nucleus? Somewhere between 440 meters and 5.6 kilometers across, big range. Couldn't pin it down because the coma was so thick, so bright for something that far out. Then the chemistry started talking. July 20th, Very Large Telescope in Chile, X-shooter and UVES spectrographs, Rohan Rahat Gaonkar, PhD student at Instituto de Astrofísica, spotted emission lines, nickel vapor, 3.88 astronomical units from the sun, 4 times Earth's distance, where metals don't vaporize, not naturally. Temperature's wrong, but there it was, clear spectral signature. James Webb Space Telescope looked on August 6th. Near-infrared spectrograph, distance, 3.3 astronomical units. Results announced August 25th. Carbon dioxide dominated the coma, not water, carbon dioxide, 10 times more CO2 than H2O, backwards from every solar system comet they'd measured. Small amounts of water ice, water vapor, carbon monoxide, carbonyl sulfide, but CO2 was king, 70 kilograms per second mass loss, water capped at 4.5 kilograms per second. Something cooked this thing different. Spherex Space Observatory confirmed it mid-August. Spectrophotometer for the history of the universe, bright carbon dioxide gas emission, water ice in nucleus, cloud extending 348,000 kilometers out. Scale matched the Webb data. This wasn't measurement error. This was composition. August 21st, Very Large Telescope again. Cyanide detected. Hydrogen. Cyanide production climbing. September 7th at 2.33 AU, 1.5 times 10 to the 25th molecules per second. September 14th, 4.5 times 10 to the 25th molecules per second, 2 kilograms per second. Tripled in a week. And nickel kept rising without iron. 4.6 grams per second nickel, 17.6 grams cyanide, no iron vapor detected. Ever, nickel and iron come together in nature. Supernova explosions make them simultaneously. Solar system comets show both. 2, I, Borisov, showed both. 3I, Atlas, showed nickel alone. Thomas Puzia's team proposed nickel tetracarbonyl decomposition. Volatile compound, breaks apart easily under UV, releases nickel and carbon monoxide. Industrial process on Earth, natural in space? Maybe. But nobody had proof. Gemini South Telescope in Chile captured it. August 27th, 8.2 meters. Gemini multi-object spectrograph, tail visible now, 30 arc seconds, 56,400 kilometers long, pointing away from the sun, teardrop shaped. Coma condensed, nuclear region bright, distance from Earth, 2.59 AU. The object was evolving. September brought more surprises. Swift Observatory ultraviolet observations, hydroxyl radicals, water vapor sublimating not from the nucleus but from ice grains in the coma, 4,000 to 10,000 kilometers out from the center. The grains were ejected by CO2 outgassing, then evaporating in space, fine grains, under 1 micrometer, amorphous ice likely, maybe crystalline, couldn't rule it out, polarimetry from VLT, Nordic Optical Telescope, Rosen Observatory, high negative polarization at small phase angles, light oscillating along the Sun-Comet observer plane. Similar to trans-Neptunian objects, mixture of icy and dark material, reddish color from irradiated organics, tholins, same compounds that make Titan orange and outer solar system bodies red. Dust ejection rates measured from Hubble images, 6 kilograms per second of small dust particles in July, 22 meters per second for grains 1 micrometer across, 2 meters per second for 100 micrometer grains. Fast ejecta for something so far out. October 3rd, Mars close approach, 28.4 million kilometers. ESA's ExoMars. Trace Gas Orbiter and Mars Express turned their cameras. CAS's on Trace Gas Orbiter got it. 5-second exposures. Fuzzy white dot moving through the frame. Coma, visible, few thousand kilometers across. No nucleus resolution, too far, like spotting a phone on the moon from Earth. But the coma was clear. Gas and dust halo. Comet coming to life. October 21st, solar conjunction, 2.59 degrees minimum angular separation. Comet moved behind the sun from Earth's perspective. 8 days before perihelion. Nobody on the ground could see it now, but spacecraft could. GOES 19, weather satellite. An OAA geostationary bird. CCOR-1 coronagraph, instrument designed to watch the sun's corona. Picked up 3I Atlas from October 18th to 24th. Magnitude 12, faint but trackable. Then Punch Satellite Quartet, 4 spacecraft flying formation. Then Stereo A, Solar Terrestrial Relations Observatory, twin cameras, HI-1 and KIO-R2. Then SOHO, Solar and Heliospheric Observatory, LASCO C3 coronagraph. Launched 1995, still working, all watching, all recording. What they saw shocked the teams, rapid brightening. Not normal comet behavior, not at that rate. Brightness scaling with heliocentric distance to the power of negative 7.5, plus or minus 1.0, steep curve. Most Oort cloud comets at similar distances. Nothing like this. October 29th approach. Extrapolated magnitude 9, way brighter than the magnitude 11.5 predicted. Gas emissions contributing. Visible light spectrum dominated by emission lines now, and blue, distinctly bluer than the sun. Earlier observations showed red. Dust scatters toward red. Cold surfaces radiate red. 5,800 Kelvin solar photosphere is the standard. 3I Atlas should be an order of magnitude colder, redder. But LASCO and CCOR-1 photometry said blue, gas emission overwhelming the scattered sunlight. Unprecedented. CCOR-1 resolved it. Extended source. 4 arc minutes diameter coma, 300,000 kilometers. Same scale as the CO2 cloud sphere-X mapped. Glow wrapping the object, not just reflecting, emitting. October 30th, 2025, 11:47 Universal Time. 7:47 Eastern, perihelion, 1.36 astronomical units, 203 million kilometers, between Earth's orbit and Mars, closest to the sun it would ever get, hidden from Earth, visible to spacecraft, Stereo A recorded it. SOHO recorded it. GOES 19 recorded it. Punch satellites got stacked images. Marshall Eubanks and user Qualsh 4 a processed 134 frames from Punch WFI 3. Clearest view of perihelion anyone would get. Davide Farnocchia at NASA. Jet Propulsion Laboratory filed the report. Navigation engineer, PhD in mathematics from Galileo Galilei School at University of Pisa. He measured it. Non-gravitational acceleration, first evidence at perihelion distance, 2 components in the orbital plane. Radial acceleration away from the Sun, 135 kilometers per day squared, 9 times 10 to the negative 7 AU per day squared. Tangential acceleration perpendicular to radial. In the direction of motion, cometary outgassing acts like thrust. Jets of gas and dust alter trajectory. This was that. Confirmation. 3. I-Atlas was actively shedding mass. If you value documented research showing what actually happened versus speculation, subscribe. Also comment from which city you're hearing this from. This is the moment we're talking about. Real spacecraft, real data, real measurements, not theories. Facts from instruments watching in real time while Earth couldn't. Hydrogen cyanide production spiked. Temperature at perihelion, 770 watts per square meter. Enough to break weak bonds. Enough to crack open volatile ices locked in amorphous structure. Nucleus heating, surface layer ablating, estimated thickness, millimeters per year over 10-year timescales to sustain observed mass loss. What's underneath? Unknown. December would tell. Avi Loeb at Harvard compiled 8 anomalies by perihelion, published through Medium and Archive papers. First, trajectory aligned within 5 degrees of the ecliptic plane, the flat disk where planets orbit, likelihood 0.2% for random interstellar object. Second, sunward jet detected July and August. Anti-tail, not from geometric perspective illusion. Real jet pointing toward the sun, never seen in familiar comets. Third, nucleus mass 1 million times greater than Oumuamua, 1,000 times greater than Borisov. Fourth, arrival timing brought it within tens of millions of kilometers of Mars, Venus, Jupiter, while unobservable from Earth at perihelion. Likelihood 0.005%. Fifth, nickel without iron. Industrial refining signature on Earth. Sixth, CO, 2 dominance over water. Seventh, rapid brightening beyond normal rates. Eighth, blue color at perihelion when it should be red. Ninth, non-gravitational acceleration detected. Loeb proposed a scale, 1 to 10, technological origin likelihood. 3, Atlas ranked 4 out of 10, most likely natural. But anomalies stacking. Congresswoman Anna Paulina Luna submitted letter October 30th, requested disclosure of high-rise images from Mars reconnaissance orbiter. October 2nd and 3rd observations, highest resolution shots of 3I Atlas from 30 million kilometers. Letter available online. Response pending. NASA statement clear. No threat to Earth. Distance at closest approach. December 19th, 1.8 AU, 270 million kilometers, 170 million miles. No collision possibility. Trajectory confirmed hyperbolic. Not bound to solar system. Will leave forever. ESA's JUICE spacecraft passed closest. November 4th. Jupiter icy moons explore. Best view of post-perihelion object. But JUICE, using primary antenna as sun shield, can't transmit data until February 2026. What JUICE saw? Locked in the spacecraft memory. Waiting. Europa Clipper positioned to pass through plasma tail. Instruments on board capable of direct sampling. If tail intersects trajectory, Hera spacecraft also on potential intercept course. Lucy mission near Jupiter Trojans, watching. November-December window for crossings. Post-perihelion predictions. Brightness plateau or continued rise possible. Physical explanation unclear. Zhang and Badams in preprint. Outlook for 3 eyes. Post-perihelion behavior remains uncertain. Could fade rapidly, could brighten more. Unusual speed factor. 137,000 miles per hour. 61 kilometers per second. Faster than Oumuamua. Faster than Borisov. Kinetic energy enormous. Nucleus properties unknown. Composition from host system or altered by interstellar journey. 7 billion years possible age, formed in thick disk of Milky Way. Ancient star populations above and below galactic plane. Matthew Hopkins at University of Oxford presented findings at Royal Astronomical Society, National Astronomy Meeting, 2025 in Durham. Otatahi Oxford model, predictive framework for interstellar object population. 3I Atlas matched predictions. First, real-time application. Model predicts Vera Rubin Observatory will discover 5 to 50 interstellar objects during operations. 3. I was preview. More coming. Michelle Bannister, University of Canterbury, New Zealand, guesses that may be seen in the future as 3. Eye is heated by the sun will test our model. Biggest telescopes in the world already observing. One might find the answer. Nickel mechanism still debated. Daryl Seligman at Michigan State, coordinating international observation teams. Nickel being seen at far distances where it's too cold for direct nickel sublimation has been seen in solar system comets. It probably means the ice structure is complex in 3I Atlas. I mean, that nickel was in the ice along with a lot of other species. Complex ice structure. Pre-solar system formation. Primordial material. Chemical fingerprint from another star's protoplanetary disk. Where that star is, unknown. Trajectory traced back to constellation Sagittarius. Direction near galactic center. But 7 billion years of motion erases origin. Could have been anywhere in the thick disk. 50 different star systems' possible birthplaces. Carbon dioxide dominance explained by cosmic ray bombardment. Stephanie Milam, astrochemist at NASA Goddard, floating through near absolute zero void for eons, exposed to constant cosmic radiation. Cooked shell on surface where CO2 ice is created. Excess CO2 now venting. Evaporative cooling effect. CO2 sublimate rapidly, absorbs heat, lowers local temperature, delays water sublimation. That's why water's weak. Surface chemistry altered by billions of years in deep space, not original composition, modified by time, water detection itself surprised. Swift Observatory. July 30th, August 1st. Ultraviolet spectroscopy. Hydroxyl signature. Fire hose running full blast. Unexpected phrase in NASA press. Comet leaking water at distance where sun's heat should be insufficient. But it was confirmation of activity beyond predicted thresholds. November, reemergence predicted mid-month. Solar elongation increasing. Moving away from sun in sky. Visible just before sunrise. Magnitude dimming from 9 toward 12.5 by month end. Another 2 magnitudes by December end. Fading as it retreats. But December 19th, close approach to Earth is the prize. 170 million miles. Hubble will observe. Webb will observe. Hundreds of ground-based telescopes ready. Best characterization opportunity. Spectroscopy. Photometry. Chemical inventory complete. Nucleus size finally measured. Mass loss rates quantified. Questions answered or deepened. Fragmentation watch ongoing. 2I Borisov broke apart in 2019. Nucleus split. Activity surged, then faded. Could happen to 3I Atlas. Weak bonds holding nucleus together. Perihelion heat, 770 watts per square meter. Enough to crack ice. Enough to separate chunks. If it fragments, surface area increases. Sublimation accelerates. Brightness spikes, then drops as pieces disperse. No fragmentation detected yet. Brightness steady. Increasing. But December will show damage. Soil core analogy doesn't work here. No soil, but heat penetration depth calculable. Millimeters to centimeters per orbit if it were a solar system comet. But this is one pass, one shot at the sun, heat wave propagating inward, surface ablates, subsurface stays cold. Thermal gradient steep, stress cracks form, ice sublimates asymmetrically. Jets form, jets cause spin changes affect orientation affects how Earth sees it in December, rotation period unknown, light curve data insufficient, too far, too faint most of the year. Spacecraft observations near perihelion couldn't resolve rotation. December might, if brightness varies periodically. If nucleus irregularly shaped, rotation signature will show, period will emerge. 8 hours, 12 hours, who knows? Shape inference from rotation, elongated. Spherical, contact binary, possibilities open. Density estimates impossible without mass. Mass requires gravitational perturbations of other objects or very close flyby measurements. Neither available. Size range wide, 440 meters to 5.6 kilometers. If 440 meters and density typical of comets around 600 kilograms per cubic meter, mass is roughly 30 billion kilograms. If 5.6 kilometers and same density, mass is 6 times 10 to the 14 kilograms. 6 orders of magnitude uncertainty. Spectroscopy and brightness can't solve this. Need resolved images. December close approach. Hubble's resolution at that distance. Still probably not enough. Webb's infrared. Maybe. Maybe not. Trajectory after Earth close approach continues. Venus past November 3rd. 0.65 AU. 97 million kilometers. No spacecraft there to observe. Venus lost to Katsuki orbiter recently. Dead spacecraft. No observations. Lost opportunity. Then Jupiter, March 16th, 2026, 0.36 AU, 54 million kilometers. Juno spacecraft in Jupiter orbit. Might observe. Europa Clipper arriving Jupiter system. Might observe JUICE en route. Might observe 3 spacecraft potentially watching at Jupiter distance. Then 3 I-Atlas leaves forever. Escape velocity from solar system at Jupiter's distance, roughly 18 kilometers per second. 3 I-Atlas moving 61 kilometers per second, 3 times escape velocity. Hyperbolic excess velocity enormous. Sun's gravity barely curves its path. Trajectory bends, doesn't capture. Passes through, gone. Timeline discovered July 1st. Perihelion, October 30th. Earth close approach, December 19th. Jupiter flyby, March 16th. Exit solar system boundary maybe 2027. Depends on where you draw the line. Heliopause, termination shock. Scattered disk edge, by 2030, definitely gone. Interstellar space again, headed in new direction. Velocity vector altered by sun's gravity, not much. Few kilometers per second change. New heading through the galaxy, won't return for millions of years, if ever. Galactic rotation will carry it. Differential rotation of thick disk, 7 billion years from now. Unrecognizable orbit. Chemical composition summary for clarity. Carbon dioxide, 70 kilograms per second. Water, 4.5 kilograms per second. Cyanide, 17.6 grams per second. Nickel, 4.6 grams per second. Iron 0 detected. Carbonyl sulfide present. Carbon monoxide present. Hydroxyl radicals present. Organics, likely. Tholins confirmed by color. Dust grains multiple sizes. 1 micrometer to 100 micrometers. Ejection velocities 2 to 22 meters per second. Coma diameter 300,000 kilometers. Tail length 56,000 kilometers at August 27th. Nucleus diameter uncertain between 440 meters and 5.6 kilometers. Comparison to solar system comets. Halley's comet nucleus, 15 by 8 kilometers, produces similar coma, but Halley's water-dominated, 67 P. Churyumov-Gerasimenko, Rosetta mission target, 4 kilometers across, rubber duck shape, 2 lobes, water ice dominant, organics present, some CO2, but water leads. 3. I-Atlas inverted ratio, CO2 dominant, water secondary, different formation environment, different star, different protoplanetary disk, different temperature zone, different chemical abundances. Oort cloud comets from our system show variety. Some CO2 rich, long period comets from deep freeze, but none as extreme as 3 I-Atlas. None with nickel to iron ratio this skewed, none brightening this fast this far out. 3. I-Atlas occupies its own category. Interstellar composition class, sample size, 3 objects. Too small to generalize, need more. Vera Rubin coming online. Legacy survey of space and time starting. 10-year survey. Billions of objects cataloged. Interstellar visitors flagged. Maybe dozens, maybe hundreds. 3 I-Atlas is preview of what's coming. Temperature at perihelion recalculated. 1.36 AU means roughly 530 watts per square meter, absorbed if albedo-typical. Surface temperature reaches maybe 200 Kelvin. Cold by Earth standards, enough to sublimate CO2, enough to crack water ice, enough to trigger activity. Temperature gradient drives everything. Surface hot, interior cold, thermal stress fractures, gas pressure builds, cracks open, jets erupt. Observed phenomena explained. Jet orientation matters. Summer jet observed July and August. Rare. Most comets show jets perpendicular to solar direction or away. Sunward jet requires specific nucleus orientation and volatile distribution. Active area facing sun. Pressure release towards sun instead of away. Indicates non-uniform surface composition, patchy ice distribution, active regions separated by inactive crust, pointing towards sun instead of typical antisolar, unusual geometry. Another anomaly, spacecraft fleet summary, Hubble captured July 21st, Webb observed August 6th. Swift saw July 30th and August 1st. SphereX watched mid-August, TESS pre-discovery, May 7th to June 3rd. Vera Rubin pre-discovery, June 21st to July 3rd. ExoMars, TGO, October 1st to 7th. Mars, Express, October 1st to 7th. Goes. 19, October 18th to 24th. Punch perihelion observation, October 29th, Stereo A, September through October. Soho, September through October. JUICE, November 4th closest approach, but data delayed until February. Europa Clipper, potential tail, intercept. Hera, potential intercept. Lucy watching. Gemini South, August 27th. VLT, July 20th through August 21st. Nordic Optical Telescope, July 2nd. Canada, France, Hawaii. Telescope, July 2nd. Lowell Discovery Telescope, July 2nd. Deep Random Survey. Chile, July 1st Discovery. That's the instrument network. Ground and space, coordinated, global, real-time tracking of interstellar visitor, public engagement, Shadow the Scientists program, August 27th, Gemini South Control Room in Chile. 2-hour Zoom session. Students from Hawaii and La Serena joined, public across Europe, New Zealand, South America watching. Karen Meach at University of Hawaii led, Bryce Boland from Eureka Scientific guest expert, live spectroscopy, live imaging, educational outreach during active science, rare access, follow-up session planned November when 3I reemerges, Gemini North in Hawaii, public invited again, unistellar network involved, global citizen astronomers, SETI Institute coordinated, near continuous photometric data, brightness measurements, outburst detection, pre-solar conjunction showed unexpected brightness surge, exceeded predictions, data shared real-time, contributed to understanding, amateur telescopes, 3 to 4.5 inches aperture, sufficient to detect, magnitude 12 range, plate-solving smart telescopes, remote observatories, Chile, Arizona, Hawaii, Australia, worldwide network tracking one object, data accessibility, most observations published through Austier's preprint server, rapid dissemination, peer review follows, but data available immediately, spectra downloadable, images available, transparency, open science, NASA archives, public, ESA archives, public, anyone can analyze, independent verification, possible, not hidden, not classified, not secret, publicly documented interstellar visitor, media speculation versus reality, mothership claims unfounded, no evidence of artificial structure, no radio transmissions detected, no deviation from gravitational and outgassing forces, no geometric shapes, no surface features indicating construction, comet behavior consistent with natural object experiencing solar heating, anomalies present but explainable through exotic but natural chemistry and formation history, Loeb's technological hypothesis, acknowledged by Loeb himself as lower probability than natural explanation. Scale rating 4 of 10 means 60% natural, 40% room for investigation, not proof of technology, not dismissal either, scientific agnosticism. Evidence leads, speculation follows, not reverses. Planetary Defense Protocol claim false. NASA did not trigger defense protocol. 3. I-Atlas posed no threat. Distance always safe. Trajectory never intersected Earth. No protocol needed. No protocol triggered. Claim appeared in fringe outlets. Debunked by NASA statements. October. No evidence supporting. Deepfake videos circulated late October. Fake Loeb claiming NASA hiding evidence. Fake physicists admitting alien origin. Detection markers present. Lighting inconsistencies. Audio sync errors. Pixelation around face edges. Verified by checking official channels. Real Loeb statements only on Medium blog, archive papers, verified interviews, real NASA statements on official website, verified social media, deepfakes targeting public confusion, successful at generating clicks, unsuccessful at changing facts, security concern real, unauthorized use of leading scientists' likenesses, identity theft, information warfare, public trust erosion, recommendation, verify sources, check official channels, cross-reference claims, don't share unverified clips, report deepfakes, platforms removing as flagged but lag time allows spread, education reduces impact, critical thinking essential. December 19, close approach brings final clarity. Spectroscopy will reveal if mass loss continued post-perihelion, if fragmentation occurred, if composition changed as subsurface layers exposed, if nucleus smaller than pre-perihelion estimates due to ablation, if rotation changed due to outgassing torque, if new jets formed, if activity declining or plateauing or increasing, answers coming. Post-December observations continue through January-February, fading but trackable with large telescopes. 8-meter class can follow to magnitude 14, maybe 15. Hubble can track longer, Webb can track longer, but practical limit approaches as distance grows and brightness drops. By March, Jupiter flyby, probably last good look, then it's gone. Dataset complete, object leaves, analysis continues for years. Scientific legacy, third confirmed interstellar object, first with detailed chemical analysis, first observed from pre-discovery through perihelion to departure, first with multi-spacecraft coordination, first with comprehensive spectroscopy revealing formation environment, first demonstrating CO2 dominance, first showing nickel without iron signature, first with sunward jet documentation, first with rapid brightening characterization, first with citizen science involvement, first with deepfake disinformation campaign, most documented interstellar visitor ever, baseline for future comparisons. Implications for interstellar object population. If 3I Atlas represents typical composition from thick disk formation environments, expect more CO2-rich objects. If age estimates correct at 7 billion years, Gamas, expect ancient population predating solar system passing through continuously. If Matthew Hopkins' model correct, always one interstellar object within solar system at any time. Detection rate, limited by telescope sensitivity and sky coverage. Vera Rubin changes that. LSST begins. Detection rate increases, sample grows, statistics improve, understanding deepens, implications for planet formation. If interstellar objects carry organic molecules, volatiles, metals across star systems, panspermia hypothesis gains support, not life traveling. Building blocks, traveling. Comets, seeding planetary systems with materials from other systems, chemical exchange between stars, galactic mixing on billion-year timescales. 3. Atlas data supports, organics present, volatiles abundant, complex chemistry demonstrated. If duplicated in other interstellar objects, model strengthens. Implications for astrobiology. If carbon-rich interstellar objects common, if they deliver organics to young planetary systems, if similar objects bombarded early Earth, origin of life scenarios gain prebiotic chemical sources. 3. Atlas composition. Cyanide detected, building block for amino acids, organic tholins present, carbon dioxide abundant, carbon monoxide present, raw materials for prebiotic chemistry, not life, ingredients for life, delivered across light years, mixing pot of galactic chemistry. Search for next interstellar object begins now. Atlas telescopes scanning, Pan-STARRS survey active, Catalina Sky survey, watching, Zwicky transient facility online, Gaia Space telescope mapping, Vera Rubin preparations final, network ready, eyes open, 4 coming, when? Unknown. Could be next week, could be next year, could be next decade, but it's coming. Interstellar space, full of ejecta from billions of star systems, some of it passes through here. We're learning to watch. Technical capability assessment, detection technology sufficient. Atlas found 3, Atlas at magnitude 19 range. Early detection allows observation over extended period. Spectroscopy capability. Excellent. VLT, Keck, Gemini, Subaru all contributed. Space telescopes, Hubble and Webb essential for detailed chemistry. Spacecraft network functional. Mars orbiters pivoted to observe. Solar monitoring missions captured perihelion, coordination effective, data sharing rapid, international collaboration smooth. Only gap, inability to send probe. ESA evaluated mission to 3I Atlas, speed too high, launch window too narrow. Technology insufficient, flyby mass 80,000 kilograms estimated, delta V requirements exceeded available chemical propulsion. Solar sail considered, deployment time too long. Mission architecture infeasible. Opportunity lost, no probe launched, only remote observation. Future interstellar visitors, advance warning required. Years, not months. Then mission possible. Comet interceptor mission, waiting in parking orbit for target. Launched 2029, will wait for suitable pristine comet, or if lucky, interstellar object. Unlikely. 3I Atlas-like object arrives when comet interceptor ready. But possibility exists. Next generation missions, longer range, faster propulsion, better positioned. 5, I might get probe visit, technology advancing. Communication time summary, light speed delay at perihelion distance 1.36, AU equals roughly 11 minutes. Commands take 11 minutes, responses take 11 minutes, 22-minute round trip, real-time control impossible, spacecraft autonomous. Pre-programmed observation sequences, confirmation after fact. At December 19th, Earth distance 1.8 AU, 15-minute delay. At Jupiter March 16th distance variable, depending on Earth-Jupiter comet geometry. Could be 30 to 50 minutes. Future interstellar object encounters at those distances require autonomous systems. Closing reality, October 30th happened, perihelion occurred, spacecraft watched, data collected, no aliens detected, no mothership revealed, no defense protocol triggered, no secrets buried. One ancient comet from another star, heated up by our sun, behaved mostly like a comet, behaved partly unlike any comet. Chemistry weird, composition unexpected, brightening extreme, color wrong, but physics held, natural processes explained, outgassing, sublimation, thermal stress, non-gravitational acceleration. All standard cometary phenomena, just pushed to unusual extremes by unusual composition and unusual history. December 19th, we'll refine estimates. March 16th, we'll close the file. Then 3. I-Atlas returns to the dark. 7 billion more years cruising the galaxy. Maybe hits another star system. Maybe gets observed by another civilization. Maybe not. Our turn ends 2026. Our data set complete. Our window closed. One more thing. NASA's Minor Planet Center database shows trajectory extended. In 500,000 years, 3I Atlas crosses paths with solar apex. Direction sun, moving through local interstellar medium. Coincidence probably, but trajectory aligned now. Aligned when it entered, aligned when it leaves. In one reference frame, random. In another frame, converging on future solar position. Math clean. Geometry interesting. Explanation insufficient. Future work required. That's October 30th without the hype. Factual timeline. Documented observations. Real science. Not speculation. Not fantasy. Not fear. Just a visitor from the stars that came close enough to study and strange enough to remember. The world waited. Mid-November 2025. The sun's glare subsided. 3I Atlas emerged from conjunction. It swam back into the view of Earth's telescopes. Fainter than the Perihelion peak. Magnitude 10.1, not the magnitude 9 spike seen by the solar spacecraft. The extreme brightening was over. Ground-based telescopes at Gemini North and Keck confirmed. The object survived, but it was changed. The distinct blue color seen by SOHO? Gone, reverted to the familiar dusty reddish hue. The dust coma, briefly overwhelmed by gas emission, had reasserted dominance. The heat flash had passed. The object was cooling as it climbed away from the sun. Hubble revisited it. Late November. The images were sharper now, closer. The coma was still vast, but the core, the nuclear region, it was no longer a single point of light. It was elongated, then resolved. Not one object, 3, a primary nucleus and 2 smaller companions, trailing nearby. The European Southern Observatory's very large telescope confirmed. Adaptive optics pierced the haze. Fragmentation. 3I Atlas had broken apart. Not a catastrophic disintegration like 2I Borisov, a partial calving, a shedding of large pieces. This was the answer to the rapid brightening, the perihelion heat. 770 watts per square meter. It hadn't just sublimated the surface, it had cracked the nucleus. The surge in brightness was the object splitting, exposing massive new surfaces of fresh ice to the sun, the wounds opening. Then, December 19th, 2025, the prize. Closest approach to Earth, 1.8 astronomical units, 270 million kilometers, every major observatory focused, James Webb Space Telescope locked on. December 20th, December 21st, near-infrared spectrograph, mid-infrared instrument. The chemical story evolved. The coma composition post-perihelion. Carbon dioxide was still strong, 70 kilograms per second. But water vapor production had surged, a tenfold increase from the August measurements, 45 kilograms per second. The ratio was balancing. Stephanie Milam's cooked shell theory gained verification. The outer layer, modified by eons of cosmic rays, rich in carbon dioxide, had ablated, blown off during the perihelion pass. The heat wave had penetrated, reached the pristine, water-rich interior. Now that ancient subsurface ice was exposed, sublimating furiously. Webb saw the signature, crystalline water ice, not just amorphous. This implied formation in a warmer region than our Oort cloud, a different kind of protoplanetary disk. The nucleus size, finely constrained, the primary fragment. Fragment A, 2.1 kilometers across. Fragment B, 300 meters. Fragment C, roughly 150 meters. Mass estimates firmed up, well within the range of a natural comet, just a large one. The rotation. The light curve data from the fragments told the tale. Fragment A, tumbling slowly. Period. 9.3 hours. The smaller fragments spinning faster. 7.1 hours. The object was dynamically unstable, tearing itself apart through thermal stress and rotational torque. And the nickel without iron anomaly. Webb's spectrographs searched the coma. They looked for Thomas Puzia's hypothesis. Nickel tetracarbonyl, a volatile compound. They found it. The distinct spectral signature of carbon monoxide breaking away from nickel. The nickel was an elemental vapor. It was shrapnel from a chemical decomposition, a volatile metal carbonyl ice, stable only at extreme cold, explosively unstable near the sun. This was the mechanism, a natural process, but one never definitively observed in our own comets. Anomaly 5 explained. January 2026. The object faded. Magnitude 12, magnitude 13, pushing the limits of ground-based telescopes. The analysis phase began. Then, February 2026, the data dump, ESA's JUICE spacecraft, its memory unlocked. Its high-gain antenna turned back to Earth. The data from the November 4th, 2025 flyby streamed in. The closest look anyone got just after perihelion. The images were stunning. The coma structure, complex streamers, ion tails, dust tails. JUICE's magnetometer felt the bow shock, the comet's powerful interaction with the solar wind. The images confirmed the fragments, already separated. The split happened on or just after October 30th. JUICE saw the immediate aftermath. The tail intercept, did it happen? Mission directors confirmed, Europa Clipper en route to Jupiter. Its trajectory had intersected the outer ion tail in late November. A glancing blow. The plasma instrument registered the hit, exotic ions, carbon ions, nickel ions, direct sampling, interstellar nickel atoms. Inside an Earth-built machine, a first Hera spacecraft missed, trajectory too far. Lucy mission observed from a distance, its images used for parallax, pinpointing the orbit. March 16th, 2026, the Jupiter flyby, the final farewell. 0.36 astronomical units, 54 million kilometers. Juno, in orbit around Jupiter, pivoted its instruments. JunoCam, GRAM, UVS, not designed for this, but capable. The images were faint, low resolution. A fuzzy blob passing against the backdrop of Jupiter's swirling cloud tops. The final photograph. 3I Atlas fell past the giant. Its trajectory bent one last time. A minor gravitational assist. Velocity increased, 62 kilometers per second. Escape confirmed, heading out. Forever. The file closed. The anomalies reviewed. Avi Loeb's list. 1. Ecliptic alignment. Still anomalous. A 0.2% chance. 2. Sunward jet. Explained. A new active site on a fragment, blasting sunward before rotation carried it away. 3. Mass. Explained. Now measured. 4. Timing. Still anomalous. A cosmic coincidence. 5. Nickel without iron. Explained. Nickel tetracarbonyl. 6. Carbon dioxide dominance. Explained. The cooked shell theory. 7. Rapid brightening. Explained. Fragmentation event. 8. Blue color. Explained. Extreme gas emission at perihelion. 9. Non-gravitational acceleration. Explained. Fragmentation and asymmetric outgassing. 9 anomalies. 5 definitively explained by natural, if exotic, processes. 2. Alignment and timing remained statistical longshots. The technological likelihood scale slipped from 4 out of 10 back to 1, maybe 2. A weird comet, an ancient comet, but a comet nonetheless. The legacy settled. The excitement over. 3I Atlas was the new benchmark, the object that proved interstellar chemistry was complex. That formation, environments varied. That cosmic rays modified surfaces for billions of years. It proved the observation network worked. Hubble, Webb, JUICE, Juno, ground-based coordination, successful. The data archive would occupy graduate students for a decade. The hunt for 4I intensified. Vera Rubin. Observatory achieved first light in Chile. The legacy survey of space and time began. The floodgates were opening. 3I Atlas was the messenger. The universe was sending more. We were finally ready to watch.